last time we started the curved linear motion, and we talked about the projectile motion, right? So when you have a problem in the exam and there's a projectile motion, you use Cartesian coordinate system, XY coordinate system. Why? Because mostly the motion components are in X and Y. Like the gravity is in negative Y direction. The velocity, even if I give you the velocity not in the X, not in the Y, but usually I will give you an angle to find the component X and the component Y, and divide the motion as an X component and Y component, and deal with the motion as a linear velocity. Why? Because I analyze the curved motion into two directions, and the two directions are linear, X and Y. That's why we substituted in the linear motion equations, right? You guys remember? We divided them X and Y. Right now, we're not gonna do this again. We are gonna deal with the curved linear motion, curve it as is. Like how? So here, we are gonna deal with motion that we cannot put them in a curved linear way, in a linear way. It's called tangent, like let's put it here, chapter 12.7, curved linear motion, tangent, normal. Or we can put it as Tn. So how this is going to be, it's not projectile motion anymore. It's like the body is moving on a curve, and usually this curve is not like a circle, like it's not constant. The radius is not constant. Radius may be changing. When you move here, the radius, the center of the radius here. When you come here, the radius is in a different location, okay, with different value. So for example, let's say I have this curve, and this curve is going to have a radius. I'm not going to call it R. We usually call the radius when it's a changing, we call it rho. Okay? So maybe the body is here, and after some time the body has different rho here after cutting distance ds. And this is the angle theta between position 1 and position 2. So how can we deal with this type of motions? The thing is, we need to understand the motion first. Let's say that my body is moving in a curve that has an equation y equal to sine 2x. That is the curve that my body is moving on. So can you guys draw this function? Do you know how to draw a sine curve function? If I have x on the y-axis and y here. So do you guys know how the sine function look like? So what is the value here? What is sine at 0? 0. How about at the value at pi over 2? 2. Okay, so if I put x equal to pi over 2, so it's going to be 2 multiplied by pi over 2 is going to be pi. Pi is 180 degrees. What is the sine of 180 degrees? 0, right? So this is going to be something like this, and then it's going to make something like this. Why? Because this is not x. If it's just x, like not 2x, this is going to be pi, not pi over 2. All right, so this is the curve that my body is moving on. So let's say the rigid body is here. So as I told you, the direction of the velocity is always tangent to the path of the motion, right? So I have my velocity is tangent like this. This is v, and it's always in the tangent direction. I don't have to write its tangent because there is no component in the normal direction. Always the velocity is tangent to the curve. If you are driving your car and you are taking an exit, and this exit on a curve, your velocity is always tangent to the curve. All right, how about the acceleration? The acceleration usually have two components. One tangent to the curve and the other is normal to the curve. It has a component, let's say it's this way, it is always normal, it's an, and another one is tangent, a tangent. So basically, if I put the a tangent here, so the resultant of this acceleration usually is something like this, in between the two components. That is the total acceleration. So what is the difference between the tangent component and the normal component? All right, we need to understand this very well. Let's say I have my car driving and then try to take an exit. The tangent acceleration is the acceleration that characterizes if you are slowing down or speeding up. Like let's say in a problem I told you that you are moving on a curve with a velocity 60 miles per hour, and you are slowing or you are accelerating or decelerating with a rate of 10 miles per hour. So that means it's a tangent acceleration. So that is, as I wrote it here, the A tangent is the time rate of the change of the velocity magnitude. So the velocity magnitude is increasing with a value or decreasing with a value. That's a tangent acceleration. But the normal acceleration is the time rate of the change of the velocity direction. So let's say that you are moving on a curve. The normal acceleration, basically, it keeps you in the curve. If you lost this normal acceleration that grabs you inside the curve, your car is gonna be thrown out of the back. Okay, so the normal acceleration is keep changing the velocity. Like let's say that you are trying to move on the curve, you want to make this. What keep changing the velocity direction that way is the normal acceleration. Keep pulling you so you don't be thrown out of the curve that you are moving on. Do we get that? So the tangent acceleration is the time rate of a change of the velocity magnitude. Like how the magnitude is changing. Is it increasing or is it decreasing? But the normal acceleration is the time rate of the change of the direction of the velocity. Your velocity needs to be on the curve. If you lost this at any specific point, like if you lost your normal acceleration, you are going to be thrown out of the curve. Like let's say that you have an exit and then you have to make that curve. If you, at some point here, you don't need any normal acceleration because this is the straight line. But once you try to hit the curve, you need some normal acceleration to keep the speed, to change the velocity direction so that you can be on the curve, okay? If you lost your normal acceleration at any point, you are gonna be thrown away. And actually that's the same concept when it comes to planets and space. They are in an orbit. If they lost the normal acceleration, they're gonna be out of their orbit. So to maintain their orbit, like they need to have a normal acceleration. Okay, so let's pass this. All right, let's go back to this curve. Let's say I want to find what is the direction of the velocity here. It's going to be tangent to the curve, and it's going to be something like this. All right, I know where is the direction of the velocity. Same thing, if your body is moving here, that's the direction of the velocity. That is the direction of the velocity. It's always tangent. But the acceleration, and when I talk acceleration, I need to talk two components. Tangent and normal. When we talk velocity, we talk only one component because it's all in the tangent direction. All right, so if I have a tangent acceleration, and I told you that the tangent acceleration is that way at this point, this is the A tangent. Is this body accelerating or decelerating? The velocity is this way, and the acceleration is this way. That means the acceleration is in the different direction or in the other direction of the velocity. That means this body is decelerating. The velocity is slowing down. And the normal acceleration is always perpendicular to the tangent, and it is in the direction of the center of curvature. Okay, so it's always normal to the tangent, and it's always to the center of the curvature. Same thing here. It's always normal on the tangent, and it's going to the center of the curvature. Same thing here. If you want to find out the tangent and normal for this curve, this is the tangent direction, and this is the normal direction. It's always going to the center of the curvature. Here, this is the tangent, and this is the normal. Here, this is the tangent, and this is the normal, okay? So it's always going to the center. So that's the first thing that you have to decide. I'm gonna ask you, tell me, if the body's moving that way, where is the tangent direction? Is it that way or that way? Up or down? And you are going that way. So it's always up. That way. Where's the normal? Is the normal that way? No, it's always going to the center of the curvature. This is the normal direction. So first you have to know where to draw your axes, the tangent and normal. Tangent is in the direction of the velocity, and it's always tangent to the curve. And the normal is perpendicular to the tangent. So one element left, which is which direction, up or down? It's always in the direction of the center of the curvature. All right, so I want to just write one equation. I'm not going to ask you to prove it, but the proof you can find it in the textbook. Some problems, I'm not going to give you what is the radius of the curvature, like what is the radius here of this curve. I'm not going to give it to you, but I might give you the function of this curve y as a function of x. Like let's say I'm going to tell you that y is equal to 2x squared plus 3x. Okay? So there's an equation, and I believe it's in the equation sheet. It says that the radius of any curve, rho, is equal to 1 plus dy dx squared, and all this is to the power 3 over 2 divided by the second derivative of dy dx squared. So if you have a curve, and this curve has a changing y over x, so every point has different radius. If you want to find the radius at a specific location, so you need to find the first derivative of the equation with respect to the x and the second derivative, and then you are going to find the equation of the radius. Let's say the equation of the radius is going to be, I don't know, maybe 3x plus 2, something like this. Then if you want to find the radius at x equal to 1, then you substitute with the equation with x equal to 1, just for example. Or you find dy dx of this function is going to be 4x plus 3. And then you find the second derivative, d squared y dx squared. It's going to be 4. Substitute, you find this at x equal to 1, and you get this value, and you get this value, and you substitute this equation, you are going to find the value of rho. Okay? All right, so that's how you find the radius of any curve. You are going to use this equation. Okay, so let's solve a problem and see how problems look like. Right, so this example is saying when the skier reaches a point A along the parabolic curve path. So we have a parabolic curve. And this is point A. Okay, this is line and this is curve. And the equation of this curve, I give it to you. Y equal 1 over 10 x squared. Over 20, not 10. And you have a skier here is gonna ski down this road on this curve. And the distance here is 10 meters. And the height here is 5 meters. And if I didn't give you the height, you can substitute in this equation with x equal 10. So this is going to be 100. 100 over 20 is going to be 5 meters. Okay, so I told you that there's a skier here, a guy, at this location, and is going to ski down this road. Right, I gave you some information about the skier. I told you that this skier, it has a speed of 6 meters per second. Speed, that means velocity. And by the way, I said velocity as a speed, that means he gives you the magnitude. He didn't give you the direction. Okay? Speed is 6 meters per second. Right? I told you speed. But I know where is he's gonna move. He's gonna move on this curve at point A, so I know the direction. I can find the direction. Like I know that this is skier is moving on this curve tangentially because you use your background information, your knowledge that you know, that the velocity is always tangent to the curve. So I draw a tangent, and this is V. I know the magnitude. If I want to know the direction, what should I do? Can you tell me how you can get the direction of V? The direction of V, I mean, like, what is the angle with the result? There. Do you know if you have a curve y equal 1 over 20x squared, you can use the equation of the curve to get the tangent or to get the angle? Basically, you differentiate this equation. If you differentiate dy dx, that is the tan theta. You guys know that? If you differentiate the equation, this equation, at any point, you get the slope at any point, and the slope is the tan theta. That's one thing you should have known from math. Okay, but anyway, let's do it for now. So I told you that this sphere has a speed of 6 meters per second, which is increasing at 2 meters per second squared. What is the 2 meters per second squared? That's acceleration. Is it tangent or is it normal? Accelerating. It's tangent. Why? Because the normal acceleration is not decreasing or decreasing. It's not the time rate of a change of the magnitude. It's the time rate of the change of the direction. So you have to solve the text or the wording of the problem first. So when I say a velocity speed, you know the magnitude of the velocity. When I say the velocity is decreasing or increasing with a specific rate, that means I give you the magnitude of the tangent acceleration. I give you a tangent is equal to 2 meters per second squared. What else is given? Nothing is given. So what I'm asking for, determine the direction of his velocity and the direction and magnitude of his acceleration at this instant. So I'm asking you to determine the velocity direction. I didn't ask for the magnitude because he already gave you the magnitude. He's asking for the direction. And he's asking for, look at this, the direction and magnitude of his acceleration. Since he asked for the magnitude and the direction of the acceleration and he leave it as an acceleration, that means we have to find the normal acceleration and get the magnitude of the total acceleration, including the normal and the tangent. Why? Because as I told you, V is always in the tangent, like it has a magnitude V and ut hat in the tangent direction. So we can actually name the tangent ut hat, or we can name them as a t hat, or we can name them as et hat. You can use whatever. This is the unit vector of the velocity. Okay, so you can say this is t hat and this is n hat. So I know that the velocity is always in the direction of the tangent. The acceleration have two components. A tangent, one of the A tangent is always in the t hat direction, and the normal, which is in the un hat direction. So it has component in the tangent and component in the normal direction, like these. This is the tangent, and this is the normal. So rather than having a normal as a vector, like a normal vector is the magnitude an in the un hat direction, and the a tangent vector is the magnitude in the u t hat direction. Do you guys get that? The same thing when we described the acceleration before as a is ax in the I hat direction plus ay in the j hat direction. And before we described the velocity as vx in the I hat direction plus vy in the j hat direction. Here I have two components. Why? Because the velocity, let's say I have this velocity. All the velocity is in the tangent, but if you want to find the x component, you are going to find that it has vx and vy, two components. Or you can use the velocity as one component in the tangent direction, and that's what we are doing here. Okay, let's get back to our problem. So right now I have the velocity, and the first thing that I want to find out, number one, the direction of the velocity. Number two, I want to find the acceleration as a vector, magnitude and direction. And if you want to find the acceleration, you have to have two components, a tangent and the t hat direction plus a normal and the un hat direction. I already have the at, but I don't have the a normal. So before I solve this problem, I should have taught you some basics on the position, velocity, and acceleration. So if you guys remember, before we study any type of motion, we study position, velocity, acceleration. We need to describe all of them. So how we can describe all of them. So let's see how the way that we did it in the curvilinear motion, we did something like this. I erase it a little bit, like the ax, like v. We said that v is equal to vx in the I hat direction plus vy in the g hat direction. We said that a is ax in the I hat direction plus ay in the g hat direction. Same way we need to do it with tangent normal. Tangent normal, I told you that, velocity. I told you that the velocity here is v and all of it in the ut hat direction. Okay, I need you to look at this curve. So as you guys know that the velocity is the time rate of change of the position. So if a body is moving on a curve like the one that we are seeing right now, and let's say this is position 1 and this is position 2. So the time rate of change of this position is gonna give you this. So, but the thing is, in red, look at the tangent normal direction, how is it changing? So this is ds, the distance cut. A little bit. And I have the tangent direction was that way, and the tangent direction is this way. This is ut hat, and this is un hat. So what happened here? These directions are changing. This is ut hat dash, like after you move a little bit of distance, and this is un hat dash. So the velocity is keep changing. These are keep changing in the direction because the velocity is keep changing its direction to be on the curve. All right. So right now I have the velocity as a magnitude is changing, and as a direction is changing, right? Because the velocity here, maybe it's accelerating. Here is 100 miles per hour. I'm keeping increasing 110, 120 as a magnitude, and the direction keep changing. So I have two variables, the magnitude and the direction. So if I want to find the acceleration, to solve this problem, I need to get dv dt, right? All right. But before I do this, let's find what is the magnitude of the velocity. How can I define the magnitude of the velocity? The magnitude of the velocity is the same concept that we have known before. V is the time rate of the change of the position with respect to t. ds dt, right? The time rate of change of the position. I'm not looking at the direction right now. I'm looking at the magnitude. How? That it's like displacement over time. It is the same concept. But we are right now moving on a curve. ds is not a straight line. So I want to find how can I define this ds? Do you guys know how we can find ds if I know the angle? Like, let me refresh your basics. I have a circle, okay? And it has a radius r. What is the perimeter of this circle? What is the circumference of this circle? 2 by r, right? Okay. What if I want to find half of this circle? Like I want to find just this part. By r, right? What if I want to find just one quarter? Pi over 2r, right? So what we did exactly, basically, you try to find this angle. This angle is 90 degree. 90 degree is pi over 2, right? 180 degree over 2. So you multiply this angle by the radius r, so it gives you this piece. If you want to find half of the circle, you find this angle, which is pi, and multiply it by r, it gives you this. So if you want to find the length of any curve, find the angle, which is theta, and find the radius, and this s is equal to rho multiplied by theta. That's basic geometry, okay? That's what you did to get the perimeter of the circle. 2 pi r, because the radius of the circle r, and all this angle is 2 pi. But if you want to find, let's say, this piece. So this piece, you have this angle theta, and you have r. If you want to find this, it's going to be r theta. But theta should be in radian, not in degree. Don't multiply r by 30 degree. You should multiply, you guys know how to convert from degree to radian, right? So if you have a theta in degree, you multiply by pi over 180 to convert it to radian. Theta and radian, okay? All right, same thing here. If you want to find this little piece, ds is equal to the angle d theta multiplied by the radius rho. Are we all on the same page on this rule? Okay, so basically, at each instance, the radius is not changing. So basically, I can say that this is equal to d theta rho over dt. So basically, that is d theta over dt multiplied by rho. So that means that theta dot multiplied by rho. What did I do here? Direct substitution of the value of ds, which is d theta multiplied by rho, and then I put it here in my equation. I substituted ds. It's gonna give me d theta over dt, which is the time rate of change of the angle, and then it gives me theta dot. We call this the angular velocity. Okay. So right now, if you want to find the linear velocity, basically you find the angular velocity and multiply it by the radius is going to give you the velocity v. So what did I learn from here? That v as a magnitude is equal to rho multiplied by theta dot. Do you guys understand this? All right. So basically I found ds, d theta multiplied by rho, substitute in the velocity equation, it gave me this equation. So, all right, this is the magnitude of v. If you want to find the vector of v, so you put ut hat, because we know that this is in the ut hat direction. All right? Okay, so let's get to the acceleration. If you want to find the acceleration a, as we know that the acceleration a is the time rate of the change of the velocity ddt of the velocity v. But before I do this, I need to revise some basics with you. If I have a function of two variables, like let's say I have a function f z is equal to x multiplied by y, and x and y are variables. How can I differentiate this function? The derivative of the first one multiplied by the second one plus the derivative of the second one multiplied by the first one. We all know that? Oh, okay, so it's going to be, let's say that we need to differentiate this function with respect to t. So it's going to be dx dt multiplied by y plus x multiplied by dy dt. Is that right? Okay, so this is because I have two variables. Let's say I have y is constant, is not changing. So this is going to be, dy dt is going to be equal to 0. So we're going to end up with just this part. If this one is constant, okay? Right now, I have a function of two variables. Theta is changing, and the direction is changing. Ut hat is changing. So I have two variables. So if I want to find the derivative of this function, with respect to the time, I have to differentiate this and multiply it by this, and then differentiate this and multiply it with this, okay? So let's do this. So I have I'm gonna differentiate the first one. So this is gonna be rho theta double dot, right? When I differentiate theta dot with respect to the time, it's gonna be double dot, and then I'm gonna multiply it with ut hat plus this rho theta dot multiplied by dut hat dt. Are you guys agree with me on this? All I did here, rho d theta dot dt, okay? This is equal to theta double dot. What I did, the derivative of this multiplied by this, plus this multiplied by the derivative of this, like the same way that I did it over there. Okay, so this is cool, but this one I don't know. What is the value of this derivative? What is the time rate of change of the direction? To do this, I have to do a little bit intensive geometry. Not sure if it's intensive or not, but let's see. Well, by the way, you don't have to prove, I'm not going to ask you to prove any of what I'm doing. The thing is, you need to know the final functions. And actually, the final equations are already in the sheet. But you have to understand where these equations are coming from. Okay, that's what I'm doing right now. Okay, let's find this part. This part, we are looking for what is the value or the time rate of the change of the direction, of the tangent direction. I don't know this. To know this, I need to write the curve. I already have actually this curve here, but let me put it again one more time. All right, so I have my tangent direction is in this way. U tangent hat, and this is U tangent hat dash after d theta, okay? All right, if I want to put, this is un hat, and this is un hat dash. If I put these two together, if I take this and I put it on top of this, like if I have, this is my un hat, and this is my u tangent hat. And I put on top of that this thing, like I put ut hat dash and un hat dash. If I put them on top of each other, because I want to know how's the direction of the change. So my direction is that way and it become that way. That's the change in the direction. So the thing is, my velocity was here, and after distance ds, it shifted here, like it become something like this. That's actually dut hat. That's the change. Like let's say that is the tangent. That's what I'm looking for. I'm looking for the time rate of a change of the tangent direction. The tangent direction was that way, and what happened? It become that way. So it moved from here to here, and that is the direction of the movement. So that's what I'm looking for. I'm looking for this piece. If I was able to quantify what is the magnitude and the direction of this vector, I will be able to quantify dut hat. How the ut hat to change it from this position to this position, or from this to this. I know that the change in the angle between them is theta, d theta, and we are going to use the same concept of the circle. If you want to find the magnitude of the ut hat, you multiply theta by the radius. So if we consider this as a part of a curve, so if I multiply d theta by the magnitude of this, is going to give me this piece. So dut hat is going to be equal, as a magnitude, is going to be equal to the magnitude of this vector. I know the magnitude of this vector. I know that this is a unit vector. So the magnitude of a unit vector is 1, right? So if I got the magnitude of the ut hat, which I know is 1, and multiplied by d theta, right now I know what is the value of this piece, okay? And the direction of this piece, as I can see, it's a perpendicular to this, because it moves like perpendicular to this. So what is perpendicular to this? It is in the direction of the un hat direction. So if I put here un hat direction, so that is the direction and that is the magnitude. So right now I was able to quantify the magnitude of dut and the direction of dut because it is in the same direction of un hat. And as I told you, the magnitude of the unit direction is always 1. So I can say that dut hat is equal to d theta multiplied by un hat direction. Okay? So if you want to find dut hat, that's actually equal to d theta, and it's in the direction of the un hat. But I'm looking for not dut hat, I'm looking for dut hat dt. This is hat, sorry. So basically, I'm gonna divide all this equation by dt. So that means that dut hat dt is equal to theta dot multiplied by un hat direction. So I'm gonna get back to this equation. So this is gonna be equal to theta double dot ut hat plus rho theta dot, and I have another theta dot here, so this is gonna be rho theta dot sorry, not double dot, it should be dot square in the un hat direction. All right, let's say that you didn't understand anything from what I have done here. Go read the textbook, read my notes, and try to figure it out. If you didn't figure it out, just know this equation. It's in the equation sheet. That's what we need to do. We only are going to use this equation. Okay? All right, so from what I can see here, if I'm saying that the acceleration A is equal to the A tangent in the U tangent hat direction plus the A normal in the UN hat direction. So that means this is A tangent and this is A normal as a magnitude. Okay? So sometimes we write A normal in a different way. Okay, let me say, do you see the equation of V? V is equal, if you guys remember, rho multiplied by theta. If you want to find V squared, so it's going to be rho squared multiplied by theta. Oh, sorry, theta dot. One second. Here. This equation. Or this one, rho theta dot. Okay. So, V squared over rho, if I take one of these rows and divide it over, or I divided the entire equation over rho, this is going to be equal to rho multiplied by theta dot squared. So what I did, this is the equation of the velocity. I squared the entire equation, and then I divided the equation over rho. It gave me this. Look, here is rho theta dot squared, and here I have rho theta dot squared. So I can write the acceleration as here equal to rho theta double dot ut hat plus v squared over rho un hat. All right, so the summary of this is going to be all right, forget all what I have done in this 15 minutes. All what I want you to know that the velocity vector is equal to rho theta dot in the ut hat direction, and the acceleration is equal to rho theta double dot in the ut hat direction plus v squared over rho in the un hat direction. That's what I want to know. All right. This is the main two equations of solving a particle moving on a tangent normal problem. Okay. All right. So let's use these equations here. So right now, I want to know, let's get back to this problem, the skiing problem. The skiing problem, again, you have a skier is moving on a curve. This curve is y equal 1 over 20 x squared, is moving with a velocity or a speed 6 meters per second, and this speed is increasing by 2 meters per second squared. So I know the velocity, I know the A tangent. Okay? So I'm asking for the direction of the velocity and the total acceleration. So the direction of the velocity, as I told you, if you want to find the direction, it's always in the tangent. And if you want to find the tangent, you differentiate the equation of the curve. So you will find dy dx, given that y is equal 1 over 20 x squared, right? Can you guys differentiate this equation? It's gonna be 1 over 10x, right? So that is the slope of this curve at any point. If I want to find the slope at x equal 10, so dy dx at x equal 10, so basically it's going to be 1. 1 over 10 multiplied by 10 is going to be 1. If you know that slope here is 1, what is this angle? If you know that tan theta, I told you that this is equal to tan theta. If you know that tan theta is equal to 1, if you use your calculator, you'll find that theta is 45 degrees. Okay? So you basically, if you want to find theta, is going to be equal to tan inverse dy dx, or tan inverse 1 is going to give you, this is 45 degrees. That means if the sphere is here and this is the velocity vt, the angle is 45 degrees. When I ask you for direction, you need to find the angle with the horizontal. Okay? Alright, so that's part number 1. Let's get to part number 2. Okay, I got the velocity direction. The second part, I'm asking you for the total acceleration as a magnitude and direction. All right, first thing, I will have to put the acceleration equation. The acceleration equation is, can you guys tell me what it is? It's over there. Rho theta double dot ut hat plus v squared over rho and the un hat. By the way, this is the tangent acceleration, and I already give you the tangent acceleration. It's 2 meters per second squared. So the value of the tangent acceleration, I know it, but I don't know the normal acceleration, but I know the components, and I already have the magnitude of v is 6, but I don't know the rho. Do you guys remember that we have an equation that can tell us what is the radius if you know the equation? So basically the radius is 1 plus dy dx squared all to the power 3 over 2 divided by the second derivative of dy dx squared. So that is the rho. Let's find dy, the first and second derivative. I already have the first derivative. Dy dx, we already got it. It's 1 over 10x. The second derivative, you guys tell me what it is. It's going to be constant, 1 over 10, right? So, this at x equal 10 meter, we got it, dy dx was equal to 1. We got it here. So, we need to substitute with this at x equal 10 meters. So, rho at x equal 10 meter is going to be equal to 1 plus 1 squared all to the power 3 over 2 divided by 1 over 10. It's going to give us a radius of 28.28 meters. I got a radius. So right now I can get the A normal, which is V squared over rho. V is given 6, so it's going to be 6 squared over 28.28, and this is going to give us a normal acceleration of 1.27 meters per second squared. Okay, look what we have now. We have the tangent acceleration, we have the normal acceleration. Right now we can get, so the acceleration is 2 in the ut hat direction plus 1.27 in the un hat direction. I want to tell you something. Always remember this equation, because this equation is very, very important. I can't forget, like if I didn't teach this class for 10 years, I will always remember this equation, that the normal acceleration of a body moving on a curve is equal to the square of the velocity over the radius. Okay? So that's actually the controlling equation of any body is moving on an orbit. Like if you have a body here, and this body, the centrifugal force that this body have here, that keep this body on this motion F, is the mass multiplied by the acceleration, so mv squared over rho. That's something I remember from my high school. This equation, that the centrifugal force of anybody that moves on a curve is the mass multiplied by the normal acceleration, and the normal acceleration is v squared over rho, the radius. So that's my, that's a very, very important equation. So anybody that is moving on a curve, always remember that the normal acceleration is v squared over rho. And I already gave you v. So all what you have to find is the radius, and you'll already be given a function to calculate the radius. So basically, square the velocity, divide them by the radius, you get the normal acceleration. So right now, you know what is the normal acceleration look like. So if this body, by the way, I didn't finish the problem. The thing is, you have to find as a magnitude and a direction. This is good, but I want to know what is the direction as an angle. Like, let's say that my body is here. So I have an acceleration in the tangent direction equal to 2 ut hat, and a 1 in the normal direction equal to 1.27 un hat. That is how the acceleration looks like. If I want to find the total acceleration, it's going to be something like this. That is it. And A as a magnitude is going to be equal to the square root of the two components, right? You have this component and this component. So the square root of 2 squared plus 1.27 squared. And this is going to give us 2.37 meter per second squared. So basically, you have a tangent component 2 and a normal component 1.27. And you want to find the magnitude. This is A tangent, and this is A normal. And this is the angle theta. Yeah, I know it's here, but this is the way how we can find them. You acceleration that way, so the one is in between them. Or you can write it here. A normal. And we can't get rid of this. So you have A tangent and A normal, so A is in between them. You have to get the square root of both of them. All right, if I want to find the angle, so the angle, I always get the angle here. It's always the angle with the horizontal component. Right now, the horizontal component is not the x-axis, the horizontal component is the tangent. So if you want to find this angle, what I did here, I just flip it and I make it like this so that you can understand. So if you want to find the angle theta, so theta is going to be equal to the tan inverse of the y component, which is the un, 1.27, over the horizontal component, which is 2, and this is going to give us, let's not name it, because theta is going to make you confused with the other theta here, so let's name this as phi. Okay, so you are going to get phi equal to 32 degree, 0.41. All right. Okay, so I have this angle is 32 degrees. If I want to find the angle with the horizontal of A, we're going to do a little bit of geometry. So right now, can you guys tell me what is this angle? By the way, this is the tangent, A tangent, and in a little bit, we found that the tangent is 45 degrees with the horizontal, right? We just found that. So this is 45 degrees. I just extended this line like this, and I made a horizontal. So in a little bit, we found this angle is 45 degrees, which is equal to this angle. So this angle is also 45 degrees, right? Can you guys tell me what is this angle if you know this angle? So let's name this angle XC. What is the angle XC is going to be equal to? 45 minus phi, which is 32.41. So it's going to give us, I believe, 12.59 degrees. Right? Okay, let's see what did I do in this problem. This problem, you have a sphere, I give you the equation of the line, and I give you the velocity and the tangent acceleration. Definitely I didn't give you the tangent acceleration directly. I told you it's a speeding or slowing down or accelerating or decelerating, and then you figure out it's 2 meters per second squared. Then I asked you to reverse the question, what is the direction of the velocity? Since from the basics we know the direction is always tangent to the curve, so I know that this is my curve. If I want to find the tangent of any curve, the tangent is the slope of the curve. To get the slope of any curve, you differentiate this curve with y. And if you guys remember this concept, if you have a line and you want to find the slope of this line, basically you differentiate the equation of the line. Like let's say you have y is equal to 2x plus 1. And if you want to find the slope of this line, it's dy dx is going to be equal to 2. That means when you move one step, you have to go up 2 steps. 1, 2. This is theta. Theta is going to be equal to 2 over 1, or tan theta. It's going to be 2 over 1. Same thing with a curve. You have y is equal to 2x squared plus 3. You get dy dx is going to be 4x, and that's the slope. And the line, the slope is always constant. So if you come here, the slope is still 2. Here, the slope is still 2. But if you have a curve, something like this, the slope here is different. It's different. Here's the slope like this. The slope is going up, it's going up. So it's keep getting changed. But here, the slope is linear. Okay? So my slope here is 4x. And always remember, dy dx is always equal to tan x. So if I ask you, tan theta, the angle between y and x, like here, the slope here, so this is theta, this is theta, this is theta. Alright? Okay, so that's my first question. Find the slope, so you differentiate dy dx, and then substitute that x equal 10 meter, and then you find theta. Second question, I ask you for the magnitude of the acceleration. You know that the acceleration have 2 components. Tangent, which is already given, 2, and then the second component is normal, which is the equation that I told you you'll never forget in your life, v squared over rho. You're already given v, it is 6, rho, you substitute in the equation that is given, you got the a normal. So you got a tangent component and a normal component. Square both of them, and with the square root, you are gonna get the magnitude, and then you get the angle. You have to do the same concept of the tan theta. Like you get the opposite on the adjacent, and then you get the angle in between them and do some geometry. Is this difficult? Well, it has a lot of stuff, but I mean, like, it's a lot of stuff, but that's dynamics, okay? And the thing is, if you are systematic and put all the equations in front of you, like once you give a problem like this, I would put these 2 equations in front of me. V hat is equal to this. This is already given, so I'm gonna put the number here. I already have V, and I can find rho. I can solve this one. And this is already given, so you have the old problem. Put these 2 equations in front of you and try to find them one by one. You solved the entire problem. Okay, we have 15 minutes. Maybe we will solve one more question. Here. Okay, record says that a race car C travels around a horizontal circular track. So you have a circle track like this, and you have a car here, and the radius of this track is 300 feet. And the car is over there, and it says that the track has a radius of 300 foot, and if the car increases its speed at a constant rate 7 feet per second square, starting from rest, determine the time needed for it to reach an acceleration of 8 feet per second square. Okay, let's take it step by step. All right, so I have the radius r, and I have the body here, and it says at this instant, the car increases its speed at a constant rate 7 feet per second square. What this is telling me? What is the 7 feet per second square? The car increases its speed with a constant acceleration. Is it tangent or normal? Tangent. So right now I know that a tangent is not changing over time, it's a constant, and it's a 7 feet per second square. That's good. All right. And I'm asking you, determine the time needed for this car to reach an acceleration 8 feet per second square. What is the 8 feet per second square? Is it tangent, is it normal, or is it total? Total, right? Because I make it general. I didn't say total acceleration, I say the time needed to reach an acceleration 8. So I didn't say it's a tangent or normal. I made it general. That means at a specific time, a time t that I don't know, the acceleration as a total became 8 feet per second square. All right, so I'm asking you about the time. Determine the time needed and what is its speed at this instant. Okay, so right now, we're gonna look right now because I'm asking about time and speed. So I need to convert AT into velocity and time. And as you remember that AT here is equal to this part, right? So, but the thing is, I'm not gonna do it that way because it's gonna be a little bit difficult. But remember that it is always the acceleration, like let's say this body was here at this point, and it became at this point, and moved this distance s. So, since the acceleration is constant, we all know that the acceleration is equal to dv dt. This is the acceleration in general, right? And I'm only talking about the magnitude that you are increasing with. So if you want to find the velocity from the acceleration, given this acceleration is constant, so I can say that v is equal to a dt, dv, sorry. So I can put here dv is equal to a dt, and I integrate this part from v node to v and from t node to t. So this is going to be v minus v node, and the acceleration is constant. I can't get it out. It's going to be a t minus t node. And you can find this equation in the equation sheet. Same equation that has a constant acceleration. So, and it says here the body starting from rest. Yeah, it says if a car increases its speed at a constant rate starting from rest, so v node is 0 and t node is 0. So I can say that v is equal to 8 multiplied by t. Already given a is 7, so v is equal to 7 t. And that makes sense. It increased its speed 7 feet per second squared. So if you multiply 7 by the time, it's going to give you the velocity. So right now I have the velocity. I need to use it to find the time needed. Here, I need to find the velocity, so I can't find the time. How can I do this? I'm going to use this instant. So he asked me, like, he told me that the tangent acceleration here, it didn't tell me about the normal. Only gave me the tangent. Here, it gave me the total acceleration at this point is equal 8 feet per second. So I can say that A is equal to, as a vector, is going to be equal to A tangent in the UT hat direction plus A normal in the U normal hat direction. Right? And the total A is going to be the square root of AT squared plus A normal squared. Are we all agree on this? That is the total acceleration value, is the square root of the tangent plus the normal. So let's say in this instant you have a tangent acceleration that way and a normal acceleration that way. A tangent and A normal. If you want to find the total A, this square plus this square under the square root. Right now, I have A tangent at this instant, and it's constant. So that means that A tangent here is the same as A tangent here. So let's see what is it changing. What is it changing definitely is the A normal. So do you guys remember what is the equation of the A normal? It is V squared over rho, right? So this is equal to A tangent, which is 7 squared, plus V squared over rho. V squared is equal to 7t, so I have 7t squared over rho, which is 49 t squared over rho, and rho is 300 foot, so this is equal to 49 t squared over 300, which is the radius of the circle. So this is going to be 49 t squared over 300 all squared. All this is equal to the total acceleration of A. So if you have this, can you find t? How can I find t? What I will do is I will square both sides, so I can get rid of the square root. So this is going to be 46. And this, I'm going to send this on the other side by negative, and then you are going to have here t to the power 4. Then you take the fourth root of some variable, and then you will end up with t here. T is going to be equal to 4.87 second. And if you want to find the velocity at 2.4 second, 4.87. So this is going to be 7 multiplied by 4.87. It's going to give you 34.1 e per second. All right, let's see what did I do here. In this problem, I gave you the radius. I told you that this body is moving with a constant acceleration all over this curve with 7 feet per second squared. From the 7 feet, I was able to get the velocity. Okay, so from I was able to get the velocity using the relationship between the velocity and acceleration and time. And I was able to get that v is equal to 7t. Once I did this, I came to the definition of the total acceleration. It's a tangent squared plus a normal squared. E tangent squared is already given. So next step is I find what is the normal acceleration. Normal acceleration is a general rule, v squared over rho. So v squared, I already have it, 17. Rho, it's already given 300. So I found as a function of t, I put it here. So I know the acceleration, I know the a tangent, and then I substitute with the a normal acceleration that I already got, which is a function of one variable. So this is one equation, one unknown, which is the t, and then I found the t is 4.87 seconds, and then if you want to find the velocity, after 4.87 seconds, you substitute with the time here, okay? All right, so with this, I already solved another two problems in the textbook. The unsolved problems. Maybe if I were you, I would put these two problems in front of me without looking at the solution, and just try to solve them and see if you are right or wrong, and then check your answer with the one here. Okay. All right. So next time we're gonna continue on the curved linear motion, and we're gonna try different axes. It's called polar axes. So we're gonna deal with r and theta rather than tangent and normal. I'm gonna be in my office until 1:30. Then I have meetings. So until 2:30. So maybe I will be available after 2:30 for 30 minutes. So if you have any questions, you can come and stop by my office. I'm gonna, in the next few minutes, I'm gonna upload the quiz, and you're gonna have the whole day to solve the quiz. But it's gonna open until midnight today, like until 11:59 p.m. And I believe you only only have 30 minutes. So once you open the quiz, you only have 30 minutes to solve the quiz. So if it closes on you, that means that your time is passed, okay? So try to use your time wisely, and also make sure that you have some time to take a picture and then upload the quiz on campus. So that you, maybe, I know some of you will use the time at the end. I'm gonna upload the quiz and then email me the answer. Try to make some time that you upload the quiz on campus, okay? All right, see you guys next time.